Chapter 9, we're going over sequences and series in this chapter. So what we're going to do is just get an example of each different situation. So arithmetic sequence, what a sequence is a sequence of numbers. So one of the easiest ones that we could think of is are the counting numbers. So 1, 2, 3, 4. This would be an arithmetic sequence because we have a common difference. So in order to get the next number, we're adding 1. So 2 plus 1 gives us 3. 3 plus 1 gives us 4. And we could kind of continue on with the rest of that sequence as just counting numbers. Or if you want to make it a little bit crazier, we could think of multiples of numbers. So we could think of 1 plus 8 would give us 9, plus 8 would be 17, plus 8 would be 25. Common difference here is going to be 8. So in order to get the next number, we're just adding 8 to the previous number. So that's what would make this an arithmetic sequence. We're using arithmetic to get to the next value. So here, find the general term of the following arithmetic sequence. So the general term is just something that we could continuously use to get the next term in our sequence. So that is going to be this formula. So a sub n is equal to a1 plus n minus 1 times d. So notice that here with each value, we're adding d to it. So plus our common difference d. So let's get a little legend here. So we'll call a sub n the general term, or we could call this the nth term, because it'll give us whatever term we're looking for. A sub 1 is going to be our first term. N is going to be the number of the term. And the term. And D is going to be known as our common difference. So we have that, and let's see what we end up doing with these. So from here, a sub n is equal to a1 plus n minus 1 times our common difference. So here, looking for the general term of our arithmetic sequence, we're just finding a sub n. So from here, let's start plugging stuff in. We know what the first term is. So looking at our entire sequence here, the first term is just going to be the very first value in that sequence. So we have 3 plus, in this case, n is just going to be n. We're going to leave it as is right there. So n is going to be n minus 1. D, our common difference, is what makes each of these unique. So from 3, what are we adding to get to 11? It looks like we're adding 8. So we could do this easily by saying 11 minus 3 gives us 8. All right, and let's look at the next one. So we have 19 minus 11. That's also 8. Let's look at these two terms. 27 minus 19, also 8. So it looks like 8 is our common difference. So when we plug it in here, we're plugging in the value 8. So now let's just simplify this and see what we end up getting. So 3 plus 8n minus 8. Get it with the variable on the left side. So we would have 8n minus 5. A sub n is 8n minus 5. And we could also test this out to see if we ended up with what we needed. So this is the first So this is 1, 2, 3, 4, 5, 6. So we're looking at a sub 6. A sub 6. So in our general term, everywhere we see an n, we're going to plug 6 in. So 8 times 6 minus 5. And we should be getting that 43. So 8 times 6 minus 5. 48 minus 5. And that gives us our 43. And perfect. So we tested it for this very last term, the 6th term of the sequence, and it comes out to be true. So we could go ahead. Oh, I used the wrong one. There we go. So a sub n equaling 8n minus 5 is our general term, and that's it. If you have any questions, please feel free to ask. Otherwise, bye.